You ever been in that spot where just one little thing is holding up, well, everything else?
Yeah.
Like maybe you're waiting forever for the water to boil, when you're trying to get dinner ready. Or maybe there's that one sign off, that one approval that's just blocking an entire project at work.
Definitely. We've all been there. That feeling of frustration, the bottleneck.
Exactly. So today we're diving into a really powerful way to think about these kinds of slowdowns.
Absolutely. We're going deep on the theory of constraints, or TOC for short.
TOC. Yeah.
This framework, it comes from Dr. Eliyahu Goldratt. Fascinating guy, actually. Background in physics.
Physics, okay.
Yeah, back in the 80s, he basically applied this very logical, almost scientific approach to business problems. And he laid it all out in his book, The Goal, which is quite famous.
The Goal. Yeah, definitely a book worth checking out if this topic grabs your interest. And the core idea of TOC, it's actually really straightforward, isn't it? Like imagine any process, any system as a chain.
Yeah, a simple chain.
A chain, well, it's only as strong as its weakest link.
The single weakest link.
So in business, or really any system you can think of, that weakest link, that's the constraint.
That's it. The one thing that's truly limiting the overall flow, the speed.
So our mission today really is to unpack how finding and then strategically tackling that biggest bottleneck can lead to some, well, surprisingly big improvements.
That's precisely it. And TOC gives us a very clear step-by-step method for doing that. It's called the 5 focusing step.
5 steps, okay.
Step 1 is simply identify the constraint. You've got to figure out what is the one thing truly restricting your output or, the flow of your system.
And that could be anything, right? Like a machine.
Could be a machine, could be a specific skill that's in short supply, maybe even a policy or a company role.
Interesting. Okay, so say we've managed to spot that weak link. What's the next move then?
Step 2 is critical. Exploit the constraint. Now, this doesn't necessarily mean throwing money at it right away.
Right.
It's about making the absolute best possible use of that bottleneck with the resources you already have.
So optimizing what's there.
Exactly. Think maximizing its uptime, making sure it's never just sitting idle, streamlining its own little processes. It's about squeezing every last drop of efficiency from that current limitation.
Yeah, that makes a lot of sense. You wouldn't want your biggest bottleneck just, well, doing nothing. So once we're getting the most out of it, what then?
Then comes step 3, subordinate everything else. Now, this might sound a bit extreme.
Subordinate. Yeah, sounds intense.
But what it really means is aligning all the other parts of the system to support the bottleneck.
Oh, okay.
Their jobs, their activities, they should all be geared towards keeping that constraint running smoothly, running efficiently. It's about priorities, allocating resources to make sure the constraint is never starved for work or waiting on something.
So the rest of the system kind of focuses its energy on feeding and supporting that one critical point.
Exactly right. Then step 4 is elevate the constraint. So if you've fully exploited it, you've made everything else work in support of it, and it's still the thing holding you back significantly.
Still the bottleneck.
Still the bottleneck. Then you need to look at ways to actually increase its capacity.
Okay, so now maybe we spend some money.
Now's the time. Could be investing in new equipment, maybe bringing in more skilled people, finding innovative ways to optimize that specific step even further.
All right, so we've found it, squeezed the most out of it, supported it, and maybe even boosted its capability. Are we done? Is that the finish line?
Not quite. The 5th and final step is crucial. Repeat the process.
Okay. Why?
Because once you've successfully dealt with one constraint, guess what?
Something else becomes the bottleneck.
Exactly. You might find a new constraint emerges as the biggest limitation. Continuous improvement is really a core principle of TOC.
That's a cycle.
It's an ongoing cycle. Identify the hurdle, work systematically to overcome it, and then look for the next one.
Okay, so it's this continuous loop, finding the biggest obstacle, tackling it head on. Now, let's talk benefits. What are the real-world payoffs for going through all these steps? What kind of improvements can, people actually expect?
Oh, the impacts can be really significant. Firstly, and maybe most obviously, increased throughput.
Throughput. More stuff getting done.
Right. By focusing directly on and improving the bottleneck, you naturally increase the overall output of the whole system. More gets done in the same amount of time. Simple as that.
Definitely a result everyone wants.
Oh.
What's another key benefit?
Secondly, reduced inventory. This is a big one.
Less stuff piling up.
Yeah. When your focus is on that smooth flow through the constraint, you tend to only produce what's actually needed when it's needed.
Just in time kind of idea?
Sort of, yeah. It leads to significantly less excess inventory just sitting around, tying up cash, taking up space.
Right, because you're not pushing production faster than the bottleneck can actually handle it.
Exactly. You avoid those big piles of work in progress.
Which, yeah, saves on storage, reduces risk of things becoming obsolete. Makes sense.
Precisely. The third major benefit, then, is shorter lead times.
Faster delivery.
Yeah, because things are moving through the system more efficiently. Without those big delays at the bottleneck, the total time it takes to fulfill an order or, say, complete a project gets much shorter.
Okay, so happy customers, faster turnaround. That's a great combo. What about the internal workings of a business? Any benefits there?
Absolutely. The fourth key benefit is better decisions.
How so?
Well, TOC forces you to really understand where your biggest limitations actually are. It gives you this laser focus.
Right.
And that focus helps you make much more informed, more effective decisions about where to put your resources, where to put your effort for the biggest impact.
Okay, clarity leads to better choices.
Which naturally leads to the fifth benefit: higher profits, more output, less waste, faster delivery, better decisions. It all contributes to a healthier bottom line.
Makes sense. More in, less cost, faster cycle. And you mentioned a sixth benefit earlier.
Yes, and this one's maybe a bit softer, but really important. Improved communication.
Ah, how does that work?
Well, when everyone in the organization understands what the main constraint is and they understand why it's important to support it.
Everyone's on the same page.
Exactly. It fosters much better teamwork, better communication across different departments, different functions. Everyone's kind of pulling in the same direction towards that common goal of optimizing the flow.
Okay, that all sounds incredibly positive, really powerful, but let's be balanced. Are there any potential downsides, any challenges to keep in mind if you're thinking about applying TOC?
Yes, definitely. It's important to see both sides. One potential pitfall is that TOC can sometimes maybe oversimplify things.
Oversimplify.
Yeah, real-world systems can be incredibly complex, right? Lots of interacting parts. If you focus too intensely on just one identified constraint, you might overlook other important things happening or other issues that are starting to emerge.
That's a really good point. You fix one leak, but maybe you miss the fact that another pipe is about to burst because you weren't looking.
Exactly. That's a great analogy. Another potential issue is a short-term focus.
How so?
The strong emphasis is on fixing the immediate bottleneck, right?
Right.
That might, perhaps inadvertently, lead you to neglect longer-term strategic investments or improvements in other areas, things that might not be bottlenecks now but could be crucial for future growth or competitiveness.
So it's kind of finding that balance between the quick wins now and setting up for the future.
Precisely. Then there's the human element, resistance to change.
Ah, always a factor.
Always. Implementing TOC often requires pretty significant shifts in how people work, how processes are managed, and, not everyone is always comfortable with that or willing to adapt easily.
Yeah, changing routines is hard.
Then there's a really significant risk: wrong identification.
Identifying the wrong bottleneck. Ouch.
Yeah. If you incorrectly diagnose what the real constraint is, then all your effort, all your resources spent trying to fix it, well, they won't produce the improvements you expect.
And could even make things worse, maybe.
Could potentially make things worse, yeah. Diverting attention from the real issue.
So this sounds like a critical mistake to avoid. How do you guard against misidentifying the constraint?
It really comes down to careful analysis, good data collection, and honestly a thorough understanding of the entire system end to end, not just looking at one part in isolation.
Right, got to see the whole picture.
And finally, it's just important to remember that TOC is not one size fits all.
It's not a magic bullet.
Exactly. It's a framework, a set of principles. It needs to be thoughtfully adapted, tailored to the specific context, the unique challenges of each individual business or situation.
So it requires careful thought, customization. Okay, now it always helps to see how these concepts work in practice. You mentioned you had a couple of real-world examples of companies using TOC.
Yes, absolutely. Tata Steel, for instance. Huge steel company. They implemented TOC in one of their manufacturing plants.
Okay.
They identified a specific bottleneck in their rolling mill, a key piece of equipment that was limiting their overall production.
Right, the weak link in their chain.
Exactly. So by applying TOC principles, focusing on optimizing the operation of that mill, supporting it, They achieved a really remarkable 15% increase in output.
15%. That's huge in manufacturing.
It is. And they also got a 20% reduction in their lead time, so faster delivery too, really tangible impact.
Wow, those are seriously impressive results. What about another one?
Another great example is Philips, the electronics giant.
Sure.
On one of their assembly lines, they found that a particular testing station was creating a major bottleneck. It was causing delays, inventory was piling up before it.
The classic symptoms.
Classic symptoms. So they specifically addressed the efficiency of that testing process using TOC thinking. The result, a 30% reduction in their inventory levels.
30%.
Yeah. And a 10% improvement in their on-time delivery performance.
Again, very concrete, measurable improvements just by focusing on that one slow step.
Exactly.
And it's interesting, these examples show TOC isn't just for, like, old-school factory floors, is it?
Not at all. It's surprisingly versatile. Companies like Boeing, for example, have successfully applied TOC principles to their project management.
Project management, how?
Helping to significantly reduce project delays by identifying the critical constraints in complex projects, and even in healthcare.
Healthcare, really?
Yeah, TOC is increasingly being used there to optimize patient flow, reduce waiting times in ERs or for appointments, and just improve the overall efficiency within hospitals and clinics.
Wow. So optimizing patient journeys, essentially. That's fascinating.
It really is. It's a set of ideas that can apply almost anywhere there's a process or a system with a flow.
It really does sound like it.
Yeah.
So which industries would you say tend to find TOC most applicable? Or where do we see it used most commonly?
Well, it definitely has its roots in manufacturing, no doubt about that. And it's still a cornerstone for optimizing production lines there.
Makes sense.
Supply chain management is another huge area. TOC helps streamline the movement of goods, minimize disruptions across those really complex global networks.
Right, managing flow across companies.
Exactly. Then you have project management. There's actually a specific methodology called critical chain project management, which is a direct offshoot, a direct application of TOC principles.
Critical chain. Okay.
As we just mentioned, healthcare is a growing area of adoption, improving efficiency, patient care pathways. Retail businesses use TOC concepts too, often for better inventory management, getting products to shelves or customers faster.
Faster fulfillment.
Right. And even service industries, think call centers, consulting firms, repair services. They're finding valuable ways to apply these ideas to improve their service delivery processes and, ultimately, customer satisfaction.
So really a broad reach across so many different types of organizations. Now, earlier you mentioned a really intriguing concept within TOC, something called drum buffer rope. Can you unpack that for us?
Absolutely. Drum buffer rope, or DBR, it's a very practical kind of visual scheduling and control method that's tightly linked to the theory of constraints.
Okay, DBR, drum buffer rope.
Let's break it down. Think of the drum first. The drum represents the bottleneck,
The slowest part.
the single slowest operation in your whole process. Just like a drummer in a band sets the beat, sets the rhythm for everyone else.
Right, everyone follows the drummer.
The bottleneck, the drum, dictates the pace for the entire system. Everyone else, all the other steps, need to synchronize their work to the rhythm of that drum.
Okay, so the bottleneck is the conductor, setting the speed limit for everything.
Precisely. Now the buffer is there to protect the drum.
Protect the bottleneck, how?
It protects it from being starved of work because of, normal variations or delays happening upstream before it.
Oh.
It's a strategically placed amount of extra inventory, or sometimes even just time, that you build in right before the bottleneck.
Like a safety stock.
Exactly like a safety stock, but placed very strategically. It acts as a safety net, making sure the bottleneck always has something to work on, that it doesn't sit idle waiting for parts or information to arrive.
Okay, so it's like having a small, carefully managed stockpile right before the most critical point to keep it consistently busy. Makes sense.
Exactly. And finally, we have the rope.
The rope, what does they do?
The rope is essentially a communication signal, or a control mechanism. It extends backward, metaphorically, from the bottleneck to the earlier stages of the process.
Okay, a signal going backward.
Yeah, and it basically tells those upstream activities when to release work into the system and how much work to release.
And why is that needed?
The main purpose of the rope is to prevent overproduction, to stop the upstream processes from just churning out stuff faster than the bottleneck can handle it, which would just lead to massive piles of inventory building up.
Ah, so it pulls back on the starting steps.
Exactly. It's like a signal that pulls back, restraining the upstream processes, making sure they don't produce more or faster than the bottleneck, the drum, can actually process. It keeps everything in sync.
Okay, so it keeps the early stages aligned with the bottleneck's actual capacity, preventing that flood of unnecessary work-in-progress inventory.
That's the core idea. Let's use that toy production line example again to make DBR really clear.
Okay, yeah, the toys. Cutting, painting, assembly, packing, shipping.
Right. And the speeds were cutting at 200 parts per hour, painting at 190, assembly, that was our bottleneck, at 140.
Yeah, 140, clearly the slowest.
Then packing at 190 and shipping at 200.
Got it.
So in this DBR scenario, the assembly stage, with its capacity of only 140 parts per hour, that's our drum. It sets the maximum output rate for the entire line.
Okay, assembly is the drum beat, 140 per hour.
Right. Now, to make sure that assembly station always has parts ready and isn't held up if, say, the painting step has a slight hiccup.
We need the buffer.
We need the buffer. We'd place a buffer, maybe a specific calculated number of hours worth of painted toy parts right there, physically or logically, just before the assembly stage.
Makes perfect sense. Keep that critical bottleneck fed and busy.
Now, the rope. The rope comes into play as that signal back to the start.
To cutting and painting.
Exactly. It communicates back to cutting and painting, essentially saying, hey guys, the assembly drum can only handle 140 parts per hour, so don't release raw materials or start cutting and painting any faster than that rate.
So it prevents them from just making 190 or 200 painted parts per hour that would just pile up before assembly.
Precisely. It prevents that huge buildup of work-in-progress inventory that would otherwise occur between painting and assembly. It synchronizes the release of work to the actual capacity of the constraint.
So putting it all together, DBR creates this synchronized flow, paced by the bottleneck's capacity, the drum, protected by the buffer, and controlled by the rope to prevent waste and excess inventory.
You've got it. By implementing drum, buffer, rope, we avoid that trap of overproducing in the early stages, just because they can work faster. We minimize the waiting time and chaos right before the bottleneck, and we establish a much smoother, more predictable, more efficient flow through the whole production line, all dictated by the pace of that assembly stage.
That's a really elegant system, actually. And okay, so what happens once you have DBR running effectively? You've got the drum setting the pace, the buffer protecting it, the rope controlling release. Is that the end?
Not at all. Remember step 5, repeat the process.
Right, continuous improvement.
So the next logical step, once DBR is working, would be to revisit our 5 focusing steps, especially step 4, elevate the constraint.
Okay, focus back on assembly.
Exactly. In our toy example, with assembly running steady at 140 parts per hour, but being the limiter, the next move is to actively explore ways to increase its capacity. Well, maybe we could add another assembly worker. Or perhaps analyze the assembly task itself. Are there ways to make it faster, more ergonomic? Maybe invest in better tools, or even some simple automation for that stage.
The goal being to get it closer to the speed of the next slowest steps.
Right. The goal would be to try and get its output up, maybe towards that 190 parts per hour that the painting and packing stages can handle.
Okay, so you identify, exploit, subordinate, you implement DBR to manage it, and then you elevate it. And then what?
And then you reevaluate. Let's say you successfully elevate the assembly stage. You get it running smoothly at, say, 190 parts per hour.
Okay, big improvement.
Huge improvement. But now assembly is no longer the slowest step.
So now painting and packing, which were also at 190, they might become the new bottlenecks. Or maybe cutting at 200 is fine, but now painting and packing together are the constraint.
Exactly. A new constraint, or maybe constraints, will likely emerge. And the whole process, identify, exploit, subordinate, elevate, repeat, begins again, focused on the new, weakest link.
So it really is a constant cycle, a process of always looking for the biggest hurdle, the biggest drag on the system, and then systematically working to overcome it, then finding the next one.
That's the essence of TOC and continuous improvement using this framework.
Okay. So as we start to wrap up our deep dive today, this has been fascinating. What's the absolute key message you'd want our listeners to take away about the theory of constraints?
I think the fundamental idea, the core takeaway, is that real significant improvement often comes not from trying to optimize every single piece of a system equally.
Which is impossible anyway, usually.
Right. It comes from identifying and focusing your limited resources and attention on the single most significant constraint that's holding back your overall performance. It's really about finding that weakest link and strategically making it stronger.
Focus on the bottleneck.
Yeah.
And the core steps to remember in doing that are
Identify the constraint, exploit it fully with what you have, subordinate everything else to support it, elevate its capacity if you need to and if it makes sense, and then crucially, remember to repeat the whole cycle because the bottleneck will likely move.
identify, exploit, subordinate, elevate, repeat.
And keep in mind those powerful benefits this approach can bring, like that increased throughput, shorter lead times, and maybe remember the practical tool of drum, buffer, rope for managing the flow around that critical bottleneck.
Fantastic. So for you, the listener, as you go about your day or your week, maybe take a moment. Think about a system you're involved in. Could be a personal project, could be how your team collaborates at work, maybe even just your daily routines getting ready in the morning. What feels like the weakest link there? What's that one thing that seems to be holding everything else up, slowing things down? Could applying some of these TOC principles, even just thinking in terms of constraints, offer a fresh perspective? Could it potentially lead to some real improvements for you?
Yeah, and maybe ask yourself, what's the current drum in that system? What's actually setting the pace?
What is the drum? Definitely some interesting food for thought there.